Hello everyone, welcome to my YouTube channel. So in this video we will discuss the questions of complex analysis from SLET 2021. So question number 11 is consider the assertion and reason. So in the assertion it is given that the function e to the power 1 by z being a complex number takes every value except 0 an infinite number of times in the neighborhood of z equals to 0, and the reason is given that the function has a non-essential singularity. So what is the function? The function is f of z equals to e to the power 1 by z, and we know the singularity of this at z equals to 0 is essential singularity. So the reason is false. So in option you check reason is true, reason is true, reason is true. So all these option is cancel out. Only option A is correct. The next question is match the following list 1 and list 2. So it is given that f of z equals to sine of 1 by z. So we have to find the matching of list 1 to matching of list 2. So f of z equals to sine of 1 by z. Limit z tending to 0 sine of 1 by z. This limit does not exist. So z equals to 0 is essential singularity. If the limit does not exist, since this limit does not exist, so z equals to 0 is essential singularity. So 1 will match to these 3. 1 will, then check this. Limit z tending to a. So z tending to a, z tending to a, z square minus a square by z minus of a. Check this limit exists or not. So we can write it as z plus of a and z minus of a divided by z minus of a, and limit z tending to a. So this will be cancelled out and this limit exists. Since limit exists, so this is removable singularity. So 2 will be matching to 4. 2 will be matching to 4. Now check. We can verify the answer. 1 is matching to 3. 1 is matching to 3. Only by checking this we can take the answer. 1 is matching to 3 and 2 is matching to 4. Similarly, this from here we can check that z equals to plus minus z equals to ia is a simple pole, and this f of z equals to e to the power 1 by z is, this does not have e to the power minus 1 by z, so this does not have any singularity. So 4 is matching to 2. So the correct option is C. So the next question is f of z is an analytic within and on the circle z minus a is equals to r, and mod f of z is less than equals to m. So then which option is correct? So this is a standard result. The correct option is option B, will be less than equals to m factorial n by r to the power n. So the next question is the fixed point of the mapping w equals to this are given by. So we have to find fixed point. How to find fixed point? You know, fixed point is f of z equals to z. Now what is f of z? This is w equals to f of z. This equals to this one. So f of z is 5z plus of 4 divided by z plus of 5. This equals to z. Now from here 5z plus of 4 equals to, multiply this 5z z square plus 5z, z square plus of 5z, and this 5z cancel, that means z square equals to 4. So from here z equals to plus minus of 2. So option B is correct. The next question is consider the following statement. In option A, function f of z equals to e to the power 1 by z has an essential singularity at z equals to 0. So since z equals to 0, since limit of this, limit of e to the power 1 by z equals to 0, limit of this does not exist. So this is essential singularity. So option A is true. So A is true. Now B is the function f of z. The function f of z equals to cos of 1 by z has removable singularity. So this is false, because removable singularity means limit z tending to 0 f of z, removable singularity at z equals to 0. That means if this is removable singularity, then limit z tending to 0 cos of 1 by z, this limit should exist, but this limit does not exist. This limit does not exist. So this is not removable singularity. So this is false. So now check. Option B is false. Option A is true. Since option A is true, so either this option A or B will be correct. So since option B is false, so this can't be correct. So we can take the answer that option A is correct. So in examination, if you don't know the other options also, still you can take the correct answer by checking one or two options. So like this, in option A, since we know option A is true, so check in which options A is true. Only option you can see in option A and option B, A is true, but option C and D says option A is false, so this will be cancelled out. Now we have to verify which by checking other options also. Since we know option B is false, so we can cancel option B, since in here it is given that option B is true, so we can cancel these also. So only left option is option A, so option A is correct. So see, without checking C and D, we can take the option. So next question is match the statement of list. Again we have to match the list A to list B. Now see, first see those statements which you know. Now everyone knows that if F is entire and bounded, then F is constant. This is Liouville's theorem. So here you can see that Liouville's theorem is, see, F is bounded, F is analytic, bounded, then F is constant. So 3 is matching to 4. Now check the options where 3 is matching to 4. 3 is matching to 3, so this is cancelled. 3 is matching to 4. 3 is matching to 1, this is cancelled, this is cancelled. So by checking only one statement, we can take the correct answer. See, option B is correct. So if you don't know these all other options, then still you can take the correct answer. So the next question is the theorem: if for all z in the entire complex plane the function f of z is analytic and bounded, then f must be a constant. Again, f is analytic and bounded implies f constant. This is Liouville's theorem. Option D is correct. See, question number 56 and 57 both are same. See the question number 58. In question number 58, we have given an assertion and a reason. Assertion is the function cosec 1 by z has singularity at z equals to 0, and reason is it is not an isolated singularity. So function is given that f of z equals to cosec of 1 by z. Now we can write f of z equals to 1 by sine of 1 by z. Now when we get singularity, if this equals to 0, that means sine of 1 by z equals to 0. And when sine of 1 by z equals to 0, if z equals to plus minus n pi 1 by z, if 1 by z equals to plus minus n pi, and from here we get z equals to 1 upon plus minus n pi, where n belongs to integer z. Now see, z equals to 0 has a singularity, so assertion is true. Now we have to check the reason. That means we have to check this z equals to 0. It is not an isolated essential singularity. Now this is, we have infinitely many singularities. So limit point of singularities, z limit point of singularity. What is the limit point of this? 0. So limit point of singularity is, we know this is non-isolated essential singularity. So here it is said it is not an isolated essential singularity. So reason is also true. Since limit point of singularities are non-isolated essential singularity. So it is said this is not an isolated singularity, so reason is also true. So that means both assertion and reason is true. Then our last question is, if u equals to this and f of z equals to u plus of ib is an analytic, then we have to find f of z. So we have given u equals to e to the power x cos y minus of y sin y. So we can find u of x. since this is f of z is analytic, so it will satisfy CR equation. That means u of x will be ux by. Since we have to find f of z and we have given u, we need to find b. And how we will find b? Since ux equals to by, so first we will find ux, which will be equals to by, and then we will integrate by with respect to y, so we will get v. So like this we will find the answer. So ux will be, first differentiate this with respect to x. So this is u of x, so it will be u of x will be b of y. So b of y will be, this is e to the power x cos y plus e to the power x cos y minus y sin y. Now to find b, since this is by, so to find b, integrate this with respect to y, you will get b. So if integration of this with respect to y is e to the power x sin y, plus again integration of this with respect to y, this is e to the power x sin y, and integration of this with respect to y, plus minus e to the power x, and integration of this with respect to y is first integration of second, this is minus of cos y, minus integration ddx of first is 1, integration of second is cos y, so minus cos y will be plus cos y, and again integration of cos y will be sin y. So b is, and see this e to the power x sin y, this minus e to the power x and plus sin y, this will be cancelled out. So e to the power x sin y, and this minus is plus e to the power x y cos y. So we got plus a function of c, plus c a function of c of x will. So f of z is u plus of ib, and we have u and b. So u is e to the power x, what is our u? E to the power x cos y minus y sin y, x cos y minus y sin y, plus I, v is this e to the power x sin y plus e to the power x y cos y plus ci. Now if you match, now see, from these two terms I can take e to the power x and x common, e to the power x and x is common, so cos y and plus I sin y. Again from this two term, what I can take common? I can take common e to the power x and y, minus e to the power x and y common, so this will be sin y plus I cos y, plus I cos of y, and plus c of I. Now see, since this is cos y plus I sin y, so I have to convert this as cos y plus I sin y, so then I can take common. Since for this minus 1 I can write as I square, since I square is minus 1, so I can write as I square. Now I will take one I here, so this is again I square, and I square is minus 1, so this will be cos y plus I sin y, so I can take this term as common, cos y plus I sin y, and this e to the power x, and this is x plus of iy, and what is this? This is z, and this is e to the power z e to the power z plus this ci. Now see which option is correct, z e to the power z plus cy, so option A is correct. Now I can do this in another way. So if you substitute z e to the power z, so z e to the power z plus c of I, so now z equals to, we know, x plus of iy, and e to the power z is e to the power x cos y plus I sin y. Now if from here you can see that this is nothing but u plus of ib, and from here u is equals to, see, u will be, see, x e to the power x, this x cos y minus I into I is minus I square is minus 1 minus y sin y. See, this option is matching, so this option A will be correct. So thank you for watching my video. Please subscribe my channel.